Let's have a loud round of applause for the one and only Michael Fremer.
Okay, thank you. Thank you. Thanks for coming. The show is almost over, and I want to thank you for taking the time out to come here to see this particular demonstration of how to set up a turntable. I think everybody that has a turntable should know how to set up their own turntable. And I assume everybody here has a turntable, otherwise why would you be here? Or you're thinking of getting a turntable. So the reason why you should know how to do this yourself is because if you go to a dealer, even a good dealer, they only have so much time to devote to it, and you can devote as much time as needed to set it up the way you want to have it set up and never have to worry that it's not set up correctly because you did it yourself. And it's not that hard. If I can do it, anybody can do it, believe me. So I'm going to show you how to set up a turntable. There's more than one way to do it. There's more than one procedure to do it, but this is the way I do it, and it works pretty well. So I'm pretty confident that it's a good way to do it. So the first thing when you do this is be in a good mood. This is not fun, you know. Don't have how to fight with your wife. In my case, I don't watch Fox News before I do this. If your politics are on the other side, don't watch MSNBC, whatever. Stay away from politics. You know, don't be drunk. Be in a good mood. And then put your turntable in a place where there's good light, which doesn't include here. It's very dark here, but we'll do the best we can. So have it on a table that's fairly stable and level and not too low so you're not doing too much bending. And have it so that it's away from the wall so that if you drop a screw, it doesn't roll under something and disappear, because these little tiny screws aren't that readily available other than with your cartridge. All right, so this is a new thing I'm doing. Now, this is supposed to be the elementary turntable setup seminar, not the complicated one. But I'll start with the simple part of it, and when I get done with that, if there's time and you want me to continue, I'll continue. So first, I want to show you what this is all about. Yeah, that's great. Okay, so this is new. I've never done this part before, so this will be interesting. So my friend Wally was nice enough to make this drawing for me. So, you know, when records are made, the cutting stylus describes a straight line. So the cutting stylus is going straight across, describing a radius across the record. Most of us are playing back records with a pivoted tone arm. So it's describing an arc. So over most of that arc, there's going to be tracking error, because ideally the stylus should be tangential to the groove and just run in a straight line. There are some straight line tracking tone arms. We can talk about that later if you want, but most of us have pivoted arms. I have 2 pivoted arms. That's what I prefer at this point. I've had everything, and that's where I'm at, but whatever kind of arm you have. In any case, most arms are pivoted arms, and because of that, they're describing an arc that for the most part is not tangential to the groove. It's going to create tracking distortion. That's part of the process. 2 mathematicians in the 1930s, it's almost 100 years now, which is pretty scary, but Lofgren and Beerwald did the math to figure out the best way to minimize tracking distortion across the surface of the record. So when you buy a turntable, you'll find out that it has a 9-inch arm, that's the length of the arm, or an 8-inch arm, or a 12-inch arm, whatever it is. And that distance is really the distance from the pivot point, the arm pivot point, to the spindle. That's the actual length of the arm. And then you'll see a spec called the effective length of the arm. And the effective length of the arm is the actual length of the arm and the number of millimeters, well, I'll show it to you over here, alone if you can see it, the number of millimeters that the stylus tip literally overhangs the spindle point. That's why it's called setting up the overhang. So if you were to take your arm after it's set up and move the arm over the spindle, the stylus tip would literally overhang the spindle by a certain distance. Usually it's around 17 millimeters. So that's why it's called setting the overhang. And in the 1930s, Beerwald and Lofgren and an English writer figured out that there has to be this overhang to minimize minimize distortion. And there also has to be an offset angle to the head shell. And that can either be accomplished at the head shell, or you've seen S-shaped tone arms. Either one works. So if you look at this chart, you see the pivot to spindle distance. You see the auto power light. It blinks. When the auto power light blinks, that means your turntable is set up correctly. We can all go home. Thank you. See you later. Okay. I don't know why that's happening. Okay. Anyway, as I was saying, so we won't worry about that for a minute. I'll go back to, okay, there we go. I'm flexible. I can deal with all this kind of stuff. So, you see right here, INNP, that's the inner null point. At that point in the travel of this stylus across the record surface, there is zero tracking error. It is tangential to the groove. And then at this outer point, it's tangential to the groove. So there are going to be two null points where the stylus is tangential to the groove, and there'll be some distortion at all other points. Every overhang geometry has those same issues. So that's how this all works. And so we call it the overhang, and we're going to set it up so that there are two null points, and at those two null points there is zero tracking error. Now if you have an inexpensive turntable like a Riga or a Project, you get a piece of paper with two sets of hash marks. Anybody have that kind of thing? Okay, so those two sets of hash marks have a little dot in the center of the hash mark. Those are the two null points. So when you set that cartridge up correctly, the stylus tip will fit in both of those little points, and the cantilever will be perpendicular to the hash marks on either side. And that means that the cartridge is set up correctly because those two null points, the stylus touches at those two null points, and the cantilever is perpendicular to the two hash marks. So that's how you set that up. I'm going to use a different kind of setup gauge, which, well, yeah, you can't see that. Let me put it over here. This one has a series of arcs. You see those arcs? Each one of those arcs is for a different effective length tone arm. So it's kind of a universal type of a setup device, and I like to use this because it shows you the actual arc. But it's the same basic principle as that piece of paper that you might have. And so the first thing I'm going to do to set up a turntable is disable the turntable. So you want to get a little wedge of some kind and put it under there and stop the platter from moving. If you have a mat, a rubber mat, or a felt mat, take that off because that's a stylus buster. And the first thing we're going to do is we're going to put the cartridge on the head shell. And this is where people run into trouble right away. And I'm going to do this in real time. You know, you read instruction manuals, and you can read the whole manual in like a minute. And then you start doing these things, and you're fiddling, and 20 minutes later you've accomplished not even the first step, and you feel inadequate. But don't, because that's what this is. This is fumbly stuff, you know. So, and it's like, I call it audio Pilates. There's a lot of bending and stretching. It's very good for you. So I'm going to, yeah, we can take that out. I'm going to put the first screw into this. We're going to set up an Ortofon 2M Red, which is the least expensive in this series. It's about a $100 cartridge. It's a very nice cartridge. It works really well. If you can afford a 2M Blue, it's that much better. So what I like to do is just put one screw in so I can have access to the back of the cartridge where the pins are. Now, maybe I should turn this whole thing around so that the camera's showing that.
You're actually looking at it.
What's that?
You're okay.
I'm okay? All right, so here's where people run into a lot of trouble. You would think after all the years we've had turntables and tone arms and cartridges that the manufacturers would come up with a clip size and a pin size, standardized clip and pin size, but they've never done that, and they probably never will. So when you get to this first step, also get yourself a pair of good needle nose pliers like this. Don't use your fingers for this, it's not a good idea. I had a really good one that I drilled a hole in so that no matter how tight I I squeezed it, I wouldn't break anything. And Lufthansa confiscated it from me. She said, you can get on the plane, but not with your tool, or you can keep your tool and not get on the plane. So I had to give up the tool and get on the plane. It's really annoying. Okay, so this is where people get into trouble because they go to put this on, and these are color-coded, as you can see. And the back of the cartridge also will either have color-coded pins or it will have it in writing which is which. So you go to do this, and you try putting it on, and it doesn't want to go. It's too tough. So you push and you push, and then you slip and you break it, and you don't have a soldering iron, and you don't know how to do that, and you feel totally inadequate. Don't feel that way. This happens all the time. So if you learn anything from this seminar, it is get a toothpick. And then, if it's too tight, if you cannot fit that clip onto the pin, take the toothpick and put it inside and push it in and turn it until you open up the clip enough to get it over the pin. If it's too loose, that's not good either, because you want a fairly snug fit because you're passing a very low voltage through that pin into the wire. So then what you want to do is put the toothpick inside the clip and then squeeze down gently, because a lot of people don't do that, and they squeeze down and then they collapse and they break it, and then they feel it. This can make you feel very inadequate, but don't feel inadequate. This is perfectly fine. If you do it right, you will do it correctly and have no trouble and nothing will break. So now I'm going to put these 4 wires on here, and some people like to cross them in pairs. They think it makes less noise, it produces more quiet. I don't know. It looks nicer, I know that, but I'm not going to do it for our purposes. If you want to do that, you can do it. And in this case, everything's going on nicely, which doesn't always occur. So we're happy about that. And if your cartridge has a stylus protector like this one does, of course, leave it on. You can even take the stylus out on a moving magnet cartridge, but I'm not going to do that. Again, the more you do this, the easier it becomes. You can, if you're uncomfortable doing this, get yourself a very inexpensive cartridge, like a $20 Grado, or one of the very, very inexpensive Audio-Technicas, and try setting that up first. And if you set one of those up correctly, you'll be amazed at how good it can sound. Okay, so now I'm going to get the last one on here. Don't drink a lot of coffee before you do this either. I did that at one show, and it was pretty ugly. My hands are all shaking. All right, so now I've got all 4 on. Now I'm going to put the second screw in, and of course, we're going to be moving this cartridge forward and back to set the overhang. Do we know what the effective length of this arm is?
No, but I think it's the same as a Rega.
239, okay.
239, yeah.
Okay, that's what we're going to assume. Also, whatever turntable you buy, or whatever arm you have, you can go onto vinylengine.com and find out everything you need to know about your particular arm and turntable. They have a really good database. If you buy a used turntable on the internet and somebody drilled the hole and installed the arm themselves, you should just double check with a ruler. You can even drill a hole in a plastic ruler and double check the pivot to spindle distance to make sure it fits within the manufacturer's recommended force. So this is 230, let me see what it is there. It's 235 millimeters. So I don't think this is a Riga.
Yeah, maybe not.
Do we know what it is? Do we have the instruction manual here? No.
No.
No. We don't have the instruction manual. So, you want to look at, oh great, so this is the clear audio, this is the inspiration, the concentrate, Concept.
Yeah, it's the clear audio concept
Clear concept. Thank you, that would be very good.
with standard arm.
With standard arm. Okay, so we've done that much. Now, the next thing we're going to do, we want to get the tracking force to be approximately in the range that it's supposed to be in so we don't collapse the stylus. So I recommend that you invest in one of these digital gauges. And the first one of these was the WINS gauge in the 80s, and it was $800. And now you can get them for $70, $60. So I recommend whatever brand you want to get. So once you've been doing this a long time, you have a very good idea. Your fingers can really sense how heavy it's tracking, but until you get to that point, I suggest unscrewing the counterweight until the arm floats. I'm not going to do it, and then slowly turn it in so it will hit the record surface. And for some reason, this anti-skid. What's that? 2 grams. So eventually it's going to be 2 grams. Right now it can be anything close to 2 grams. I'm just adjusting the anti-skating, which is based on a magnet, so that the arm doesn't get pulled to the outside every time. So it's 0.59 gram. Also, I recommend putting the arm back on the rest and holding it when you do any of these things at first, so you don't slip with your finger. And the reason why we want to get it close to the final tracking force is because the cantilever is a spring, and so when you're tracking heavy, it tends to get pushed forward, and we want the overhang to be exact. This is one of the most important parts of this whole process, and you want it to be exact. So I'm at 1.8. I'm going to think that's close enough for now, because this cartridge is supposed to track between 1.8 and about 2.2, so I'm at the lower end, which is fine. So the next thing I'm going to do is I'm going to... Did you find it yet?
What do you look for? I had to remove my phone. Here's the text layer.
I'm looking for the... That's it? Okay. They're giving us the null points, but that doesn't tell. Okay, it's the overhang is 17. The over length is 302. The effective length is it's 239. Okay, it is 239. Okay, it's 239. I don't see how that's possible, but it is. Okay, so that is going to be the 4th set of arcs. So now is when it would be good for you to be, yes, over. Okay, so the first thing I'm going to do, and this is going to be the same process if you're doing it with this or if you're doing it with the piece of paper. So you're going to move the piece of paper, or this kind of gauge, until the stylus is in the groove. And if you're using a piece of paper, you're going to put the stylus on the little dot, and then you're going to turn it in the head shell till the cantilever is parallel to the lines next to it. And you're saying, well, what does that accomplish? I've just moved it to be in that position, but you'll see. So now I'm going to get down here, and I'm going to look at it. Put it in the groove. So now it's in the groove. Now I'm going to go to the end of the groove, and I see that the stylus is forward of that groove. That means I have to move it back in the head shell. If you have the paper kind, you're going to move it to the forward set of grids, and you're going to align the cantilever so that it is parallel to the hash marks next to it. And then the stylus tip is either going to be forward of the point or behind the point. If it's forward of the point, you have to back the cartridge up in the head shell a little bit, and then go back to the first null point and set it up again, and go back and forth, moving it forward and back, side to side, for a long time, until it's sitting in the dot on both hash marks, and the cantilever is parallel to the lines. And then you're done with the overhang. So here, what I'm going to have to do is move this back in the head shell a little bit, because it's forward of the head shell when it's at the other end of the arc. Now, this type of arm uses a 1-point variable You see you can move the, this that way. Most have a fixed offset angle in the head shell. This is a variable head offset angle. It's the same thing essentially, but it's slightly different. So whichever you have, if it's fixed, you're going to be moving the cartridge itself around the slot, whereas this doesn't have a slot, so the slot is actually in the center here. Instead of having slots at the head shell, the slots are in, there's one slot. All right, so now I'm going to move it back a little bit. And I'm going to do this, I'm going to start over here again at 239. Get yourself an inexpensive 3x plastic jeweler's loop so you can see what you're doing. It's in there. And I'm going to do this a few times, and if I don't get it, we'll make believe I got it, because we could be here all day. And this is the thing. This is the most frustrating part of this whole process. You'll be going back and forth a number of times. You'll be too far forward, you'll be too far back. If you get really upset at yourself or it gets frustrating, take a break, go outside. Never get mad at this thing. I'm just telling you, there's times where you get mad at it, don't get mad at it. Just imagine you're having brain surgery and the doctor's having trouble doing something. You never want them to be going, get that thing in there. You want them to be very calm. So it's the same with this. Just do it till you get it exactly right. No compromise. So I am a little bit off. So I'm going to do it 1 or 2 more times, and then we'll just make believe I got it. Now it's too far back. And over time, your fingers will get more adept at doing these little maneuvers. It's very good for you to do this kind of stuff. Okay, now it is in. It's in there, and it's in here. Okay, so now I've got the overhang set correctly. So I know the distance from the pivot point to the overhang point as specified by the manufacturer of the tone arm is set correctly. But I'm not done yet. If you have the piece of paper type of alignment gauge, you're done because you've aligned the cantilever. But with this type of gauge, and this is the next part of the gauge that I want to show you because it really explains this in detail. So here's a straight line going from the spindle to the outer edge of the record. So that's the way the record was cut. And you'll see there are 2 sets of hash marks, one here and one here. Those are the 2 null points that we've been talking about. So the next part of this process is to put the stylus tip in the null point on the line in the center of the 3 hash marks. And you notice there are 2 sets of hash marks here. There's one that says Bearwald and one says Lofgren. And those are slightly different. I like the Lofgren. There's a bunch of different alignment geometries. You can spend the rest of your life trying them all and comparing them, but I'm into this to play music, not to play with hi-fi equipment, so I like the Bearwald. And you'll notice that up here, that each of these arcs actually has a double arc, and one's for Bearwald and one's for Lofgren. So, but we've used the Bearwald, so I'm going to put this back on here, and now I'm going to put the stylus tip right on the line on the first null point. And this is where the cameraman's going to really have to do his job, because this is where it's very important that you see this. This cantilever is completely bent and twisted, you know that?
That's okay.
Yeah, well, Well, it's okay, but it's going to make it more difficult for me to show you. And I didn't do it, by the way. I had nothing to do with it. It came out of the box that way. It looked really weird to me at first. Now I see what the problem is. But we'll have to do the best we can. So now what you have to do is get directly in front of, like right in front of this style, coming right out here. There it is. Okay. You're almost where you have to be. I'll move this around so you don't have to move it. Let's see if I can. Oh, look at that beautiful. This is ridiculous. Okay, wait a second. This is so messed up. That was the bad one. You see?
Yeah, it got worse.
Yes, you see what's going on there? The stylus is actually turned inward, and the cantilever is resting on the gauge. Does this help you visualize this? No.
It should be in the groove.
Yeah, so make believe the stylus is in the groove. Now you've got to get a little more on an angle. Okay, now see if you can get a little closer and get so it's focused on the hash marks. A little further back. A little more. A little more. Almost. Okay, so let me see if I can get can you get the light a little bit above so they can see the hash marks? All right, so it's not showing up as well as I would like, but let's look at this one. You see there are these 3 hash marks, and you put the stylus right on the line and look from the front and look at this angle. Make believe this is the cantilever. So if it's like that, you have to, it's like a video game. If it's like that, you have to twist the cartridge in the head shell until it's like that. You get that? That's called the zenith angle. That's called setting the zenith angle. And unless that's set correctly, you're never going to have tangentiality to the groove because the stylus is always going to be at the wrong angle all the way across. So you're going to put it in that little mark. You're going to set it so it's tangential to the groove by being parallel to the 2 other hash marks. Where'd they go? And then you're going to go to the other null point, and you're going to move the gauge around until you have it, and it's got to be correct. You will see that it's correct because the geometry demands that. If we had that piece of paper again, where'd that piece of paper go? It's over there. Yeah. Watch yourself. So once you set the inner null point, when you go to the outer null point, it has to be correct as long as the inner one is correct. If it's not correct, then something is wrong with the setup of your arm when it was first installed. But that won't happen to anybody who's here, I guarantee you. All right, so you've got the overhang set correctly. Now you've got the zenith angle set correctly. Now you have to tighten everything down. So how tight is tight? Some audiophiles get really crazy and they make it too tight. It just has to be snug and not able to move. And so turn the screw a little bit on one side, a little bit on the other side, until it's tight. And I recommend getting an Allen key type screwdriver rather than using an Allen wrench because you may end up torquing it too much by using the end of one of these kinds of things. Then the next thing I have to do on this particular arm is tighten the, what did I do with my, oh, here it is. I have to tighten the head shell very carefully so I don't upset the the offset angle. Now, with a regular slotted tone arm, after you do this, if you've had to twist the cartridge around to get the zenith angle correct, guess what could happen? The overhang could go off. So you have to go back and double check the overhang. And if it's off, you know what that means? You're starting over from the beginning, which could be very upsetting. But if you're really careful with this and you don't loosen the screws too much in the head shell so that things aren't sliding around, if you tighten it so that things aren't sliding around and just loosen it slightly so you can twist it around in the head shell to get the zenith angle correct, you shouldn't move the overhang for the most part. So we've gotten the overhang and the zenith angle correct. That's the most difficult part of this job. The next thing we're going to do is we're going to check the stylus pressure again, because we've moved the cartridge in the head shell forward and back. That changes the stylus pressure. We're going to go for 2 grams. This is reading very, very low, which makes no sense whatsoever, but that's what it's reading, so I'm just going to go further in.
Michael, you have to tear the gauge.
Yeah, it went off. Yeah, wait a second. Okay, now let's see. Yeah, that's what it was. It's never gone off on me like that, but that's what happens. Be careful with your gauge.
Good call.
Good call. Well, Rich is an expert at this, too. I wondered why it was so far off. All right, we're almost there.
Back to where we started.
Okay, we're at 1.96, I'll buy it. All right, now the next thing we're going to set is the anti-skating. So what is that all about? So what does skating mean? So there's a tendency of the arm, of a pivoted arm, to want to move towards the inner groove of the record, to want to ride along the inner groove of the record. Now, why does that happen? If you go online, you'll see people saying it's because of centrifugal force, because the grooves, radiuses get smaller, and then the arm's moving and it builds up force and goes in, but that's got nothing to do with this. So what causes skating is friction in the groove. So when you play a record, there's friction in the groove when you play. The different vinyl formulations have different amounts of friction. The more the groove is modulated, the more friction, just like a car on a bumpy road. The type of stylus profile you have affects the amount of friction, so there's friction. Now the friction is a force that's generated in line with the stylus and with the cantilever. It goes right behind it. So since the head shell is offset from the pivot point, that force is going out here. Can you see that can you go from above? In other words, this is a line drawn from the stylus tip directly behind. So the force is actually generated back here. If the pivot point was there, there'd be no skating. But the pivot point is over here, so the arm, that energy is going to want to move inward, and that has to be compensated for with an outward force. And that's applied on tone arms either with a weight in a string, which you've seen, and that pulls the arm back towards the outer groove, or in this case, there's a magnet right here. And the more pressure we put on it, the more we turn this in, the more of the magnet that affects the arm and pushes it away further. So there are different ways of doing this. I have this device here, and I was going to show it to you, but you're never going to want to use one of these things. So, but I bring it, and it uses a string and a plumb bob, but it got tied in a knot, so I'm not going to untie it. But I use this to test how accurately the manufacturers of the various tone arms set their anti-skating devices, so I can tell readers whether it's accurate. So I found that both Project and Riga very accurate. So if you're tracking at 2 grams and they say put it on the number 2, that is actually the right place to set it. If you have a project, it'll say, if you're tracking at 2 grams, it'll say put the little loop of thread on the 2nd notch, and that, using this device, measures accurately. If you don't use anti-skating, the stylus will ride on the inner groove the whole way. If you apply too much anti-skating, it's going to ride on the outer groove all the way. So you have to average it. You'll never get it exactly correct. This is a compromise, because the amount of skating is going to change with every record you play because of the vinyl formulation, the amount of modulation in the groove, where you measure it, so it's variable. All these things that we're going to be doing here are compromises. If you want perfect, get a CD player. They're perfect. But somehow this sounds better no matter what. So just follow the instructions that come with your tone arm for setting anti-skating, and you'll be correct, or set it a little bit less than they recommend, and you can't go wrong. So the next thing I would talk about would be vertical tracking angle and stylus rake angle, but those are issues really, that goes into the advanced section of this. If you have a basic turntable, a Riga, they don't allow you to set azimuth, and they don't allow you to set stylus rake angle. So you'd be done now. You're finished, and it will sound fine. It'll sound very, very good. It's not that hard to do. Start with an inexpensive cartridge, set it up this way, get the overhang correct, get the zenith angle correct, get the tracking force correct, and you're done. It's not that difficult. If you want to take it the next step, I can show it to you. Anybody want to see the next step? Okay. The next thing we would set, and then when we're done with all of this, at the end we'd go back and double check everything, because anything that we adjust can set off everything else. So the next thing we would do is check the stylus rake angle, or the vertical tracking angle. And that has to do with when a record is made, the cutting stylus is describing an arc. The vertical modulations are describing an arc. It's not straight up and down. So ideally, you want to play back the record by describing the same arc. And the height of the arm will affect the angle that the stylus is reading that arc. So in the old days, we used to say, and I don't know how many turntable setup seminars doing it this way, put a record on the platter, put the stylus in the groove, get a grid like this. It's invisible. Can we see the grid? Can't see the grid. It's a miracle. I wonder why we can't see it. Oh yeah, okay, wait, can you focus that? Does it really pay? Anyway, there's a grid on there. Or you could just get a piece of plastic ruler that you can see, and just go to the side, and if the back of the arm has an adjustment where you can raise or lower the back of the arm, just set it so it's parallel to the record surface, and if it's parallel to the record surface, your stylus rake angle will be correct. But that's not really true. But that's what we thought for years, until we had digital microscopy with a UBS input. And that changed everything, because then we could see, well, this is what it looks like, the microscope looks like. We could actually look at the stylus, and I'll show you what we get. We get something like this. Is that showing? Oh, you're seeing nothing. You got to yell at me when you see nothing. Don't be ashamed to yell at me. Don't, you know, because, okay, so that's what it looks like. Now this is a line contact type stylus. You see that line? That's the line that contacts the groove wall. That line should be 2 degrees beyond perpendicularity to the record surface. So notice if that was perpendicular, it should be over 2 degrees. So why is that the magic setting? So in the early 1980s, 2 guys worked for Diskwasher. Some of you know Diskwasher. And they went around the country to cutting rooms all over America, and they measured the stylus rake angle of the cutter stylus. and it ranged anywhere from 91 to 93 to 94 degrees. It would change each time they put a different cutting stylus in, but it always had to be over 90, because when you cut a record, there's a thread of lacquer that comes out that you've just cut. That has to be sucked out by a vacuum. It's very volatile and flammable, so it has to be immediately sucked out. If this cutting stylus was not over 90 degrees, it couldn't do that. It would go the other way. So we know it has to be over 90. So the measurements are 91 to 93, and these guys did the research and came up with 92 as a good compromise for how your stylus rake angle should be set. If you have a spherical stylus, like a Denon 103, it doesn't matter. It's round. No matter how you change it, it's going to be round. You won't get a lot of information out of the grooves, but it's very pleasant sounding and easy to set up. And if you're not comfortable doing this, that would be a good way to start. A Denon 103R or an inexpensive. The more complicated, the more severe the stylus profile, the more important this kind of setting is. So another thing that was discovered is that, unfortunately, manufacturing is not what it should be when they make these things. So here's an example of a $5,000 cartridge. With the arm parallel to the record surface, we measured 87 degrees. So even if you said, well, I want to do this by ear, you know, I can set this by listening, this person would never get it right unless he raised the arm up like that. He's going to put it parallel and then go a little bit here and a little bit there, and he's never accomplishing anything. So digital microscopy is great if you have an expensive tone arm and an expensive system and you want to get it set up correctly. I'm not saying it's critical for the average person that wants to set up an arm, but if you want to get heavily into this, or you can get a digital camera and take a picture directly from the side and blow it up and get an idea. If you spend $5,000 on a cartridge, though, you want to know how well it was manufactured, and it's worth getting a digital microscope and doing it. Or if you're in an audio club, everybody chips in and you pass it around. So that's setting stylus rake angle. If you want to do it by ear, for the most part, if it's too high, it'll sound bright and edgy, and if it's too low, it'll sound thick and the bass will be kind of woolly. So you can sit there and play with it until it sounds the way you like it, if you want to play with that setting. So that's stylus rake angle. And the final thing is azimuth. So azimuth has to do with the perpendicularity of the cantilever to the record surface. And again, in the old days, we used to say, put a mirror on the platter, put the stylus on the mirror, and if you're able to adjust the arm, the head shell in that direction, set it so that the cantilever is perpendicular to the record surface and the mirror reflects a straight line, and you're done. But again, that doesn't really work either, because as it turns out, when they insert these styli into these cantilevers, not only is there variability in that direction for the stylus rake angle, there's variability in that direction too. And so perpendicularity may not be the right setting. And what is that to accomplish? It's to accomplish maximum separation and minimum crosstalk between the channels, because the system is the Westrex 45-45 system. So there's groove walls modulated on the right side and groove walls modulated on the left side, and you don't want any modulations that are on one side to go to the other side, and that's called crosstalk. And so you want to minimize that by setting the azimuth angle correctly. So how do you do that? Well, you can do that electronically. And rather than going into the details here, I'll say that all that information is on my DVD, which some of these guys have for sale, which shows all of this. I set up 3 turntables in excruciating detail on camera. I set up a Riga, I set up a Project, and I set up a VPI. And I drop screws and I bang into the arm, all kinds of bad things happen, and I show them because that's what happens. You know, I don't want anybody to think that even if you're experienced with this, that those kind of oops things don't happen, because they do. And I show how you can use a digital voltmeter to set the azimuth. But the point is, if you don't have an arm that allows you to adjust that, or you don't want to get too fanatical about this, if you get the overhang and the zenith angle and the tracking force dialed in correctly and the anti-skating, it's going to sound great even if you don't do the stylus rake angle thing and the azimuth thing. If you spend a lot of money on a tone arm and spend thousands of dollars on a cartridge, you do want to get all those things right. And the more severe the stylus profile, the more critical it is to get that stylus rake angle correct. So my goal here was to just demystify this process to show you how it's not that difficult to do, and to tell you that if you really want to get fanatical about it, you can go on for hours. Right, Rich? We can do this for hours. And you can use a digital oscilloscope to set the azimuth. You can use a phosgometer. You can download the Fikert software to do it. It's a whole computer program that lets you do it. It all depends on how, well, you can do it by ear. You can, if you're able to adjust your azimuth, put it over a couple of degrees and listen for soundstage width and image stability, and then move it 1 degree that way and listen again, and then perpendicular and listen. You can do it that way too. Doing it with tools makes it quicker, more accurate, and you can be certain of getting the right results. But again, if you're not willing to spend a lot of money on the tools, if you've got a $300 turntable and cartridge, there's no point in spending $300 on an oscilloscope. It depends how far you want to take this. The problem with this hobby is when you get into vinyl, it keeps getting better, and you want more, and it gets better, and then it gets much better, and when you think you've had it as good as it can be, then it keeps getting better.
Where's the medium? Where do you find something that's decent?
And a turntable?
Yeah.
You know something? If you set up a Riga RP1 correctly and put the right kind of cartridge on it, or a project, inexpensive project, $400, if it's set up correctly and you have a decent phono preamp, and I don't mean an expensive one, it should have the qualities that are better about analog than any digital format will be apparent to you.
A certain amount of money, you want to budget like half a percentage for the turntable, for the cartridge, and for the preamp. What would you bring them?
That's a tough question, but I think the minimum turntable you should buy is either a Riga RP1 or a Project Debut Carbon. So $400 to $500 can get you a pretty decent turntable. And if you get something like a Project that'll come with one of these Ortofon 2M Reds, it'll sound okay. If you switch to a 2M Blue, you can even just change the stylus out, get a 2M Blue stylus. It will get much better. And once you hear that, then you'll start with mats, and it gets pretty crazy. But a phono preamp, there's some good inexpensive moving magnet types. I mean, I had a thing on my website where we compared 5 inexpensive phono preamps, and I put files up of the same piece of music from each of the 5. And I didn't say which was which, and I didn't say which I preferred. I said, which do you like? And the readers, one of their favorites was a $99 one from a company called Nerve Audio, and I think you can find that on Amazon. And it sounded pretty good. I liked it also, $99. But if you can spend more, of course, this hobby, the more you can spend, the more you get. I don't care what anybody says. Well, above a certain point, it doesn't matter anymore. Unfortunately, it keeps mattering. But you can have a lot of fun for not that much money. I mean, I lived for years with a pair of Spica TC50s and an inexpensive Hafler electronic combination and an inexpensive turntable. Did you go up to ELAC room and hear Andrew Jones's little 220? Those are fantastic. So you get those and start out with that and a project turntable and a decent little amplifier, and you should be good to go. And then you can start collecting records and really becoming a maniac. Any questions I can answer?
Yeah. Question, is this an azimuth problem? Sometimes when I play stereo records, I can hear the beginning of a song.
You're hearing print through, which is, there's 2 kinds of print through. There's tape print through, where the signal actually prints through the tape, and sometimes the tape is bad like that, but when they cut the record, it shows up. And then there's groove print through. When the grooves are cut too close together, you get pre-echo.
So it's not necessarily an equipment problem?
No, it's not your problem. It's on the other end of the process. Any other?
So SRA, if you're 90 degrees this way, you want the tip of the stylus that goes back to 90
2 degrees forward. Forward. So 90 is perpendicular, so if you're looking from your side or looking from my side, it's like that. Because the arc that is being cut it's a sickle-like move. So it's cutting like that. 2 degrees, this is perpendicular, it's really cutting like that. Forward. Looking from the top of the stylus, the top is ahead of the actual tip. It's ahead of it.
So digging into top is forward, not the tip.
Yeah, so it's going,
Digging into it.
right. I have to have better drawing, so I'm not using my fingers all the time. So you,
I'm a needle doctor for
This is the arm. Use the pivot along the back of the
they're good. A lot of the guys online now, they really know they have to know their stuff because there's a lot of competition. So the guys that do setups at Needle Doctor's good, Music Direct is good, Acoustic Sounds, they all are good people. And they also can all recommend the right cartridge for your tone arm. Because I'm not getting into the issue of resonant frequencies and the compliance of the cartridge relative to the weight of the arm. That's all, you can find all that information online. But any of the modern turntables and tone arms are set up for medium to low compliance cartridges at this point.
Is this the right picture for me to look at?
Well, yeah, this one shows you 92 degrees because the microscopes come with software that you can use to actually measure it.
This is actually, will show you what optimum would look like, so why talk about it, we'll show it to you.
It kind of looks like it's perpendicular, doesn't it? But it's just over 90 degrees. And I know, from experience that when I talk to consumers who do this and they set it up and they get it to 92 degrees, even if the arm looks way, way up, they say now it sounds really best. But if you have that situation, you're better off getting shims and leveling it out that way, because that's not really, that's putting a force that goes in this direction that's not good for the whole system.
Would that be uneven through the tracking? Would
that too.
It would be uneven through the swing of the arm's motion.
Yeah, I mean, that's not a good situation, even though it'll sound better than if it's parallel and the SRA is setting correctly. Any other, yes?
I got a turntable, I need a stand for it. Any recommendations?
You have a stand for it, or you want to buy a stand?
I'm gonna get one.
Well, there's a lot of different theories and opinions about stands. Some could be, if you put something on the wall, that's the best. That decouples it from the floor. That's really ideal.
Can I make a quick suggestion? On the wall is 100 times better if you get heavy L brackets, mount to the wall and build a safe shelf just out of whatever materials do count. That is really, really good. Footfall and other problems are eliminated to a great extent by mounting.
That's right.
And L brackets and mounting to a wall will better almost any freestanding stand.
That's right. As long as your walls have studs that you can screw it into. Because I had a VPI turntable with their big stand, which you can fill sand and lead. I filled with sand and lead shot and had granite. I mean, this thing almost wanted to go through the floor. But if you walked near it, you'd get footfalls and it would shake. I got turnbuckles at the boating supply place and turned them out until they were touching the wall. So the stand was grounded to the wall, and that eliminated it the same way. But all that weight and all the sand did nothing. It actually made it worse because it was putting this heavy mass that was jiggling on a bad floor.
You're coupling to the floor, which is a problem.
Yep, the wall is the best thing.
What is your first system?
My system? My system's it's insane, because this is my job. That's my excuse, is that it's my job. So I have a continuum caliber and turntable, and I have a Kuzma 4-point arm and the Cobra arm that comes with the continuum, and I've got a bunch of nice cartridges that I'm very lucky to have. If you told me 15 years ago that I would have what I have now, I would not believe it. And I have a Ypsilon phono preamp, which is very expensive, but I bring files around to the show that I made on this system, and people, they can hear it. It's not crazy. It's crazy in the money sense, but if you can afford it, and you know, I made the DVD I made for my turntable, I borrowed $20,000 to make that, and my wife was very supportive. She said, I hope you don't lose the money. And so I made this DVD hoping I'd make my money back to be able to let people see how to do this. So I've sold 16,000 of them and continues to sell. And that's made me an amount of money I never thought I'd make from making a DVD, and that helped pay for all the stuff that I have. But it's the most fun in the world. For me, despite the fact that it's my job, the most fun for me is to go downstairs late at night, fire up the system, put a record on, and I've got 4,000 CDs and high-resolution files on a music server. I never sit and listen to any of it. I can't, it doesn't make me want to listen. If I put one on, in a minute I want to do something else. But if I put a record on, and especially if it's a record I haven't played in a long time, like 20 years, and my system is so much better now, I'll put that record on, it's like, I had no idea what was on that record. It's amazing. So, and it's a long-term, this is a long-term investment at this point, because vinyl's not going away. I went to a record store in some part outside of LA called Mount Analog, and it was a hipster record, so I walked in there. There was not one artist that I ever heard of. Not one. Well, maybe one or two, but it was all this different kind of music, and all these young people were coming in and buying all these records. The store was crowded. They were buying records. And people say, oh, it's a hipster thing, they'll be onto something else in a couple of years. I don't believe that. Because I still think when you play records, there's something about whatever it is, if it's an additive distortion, or I don't care, it makes it sound more real. It just sounds, the ear likes it better. And I hear that from young people all the time that have been growing up with MP3s, and you know, and then all of a sudden a friend has a turntable, and they go, wow. And it makes you relax, and it makes you really want to listen. You know, I'm not hallucinating that stuff. I know that it's true, because
there's actually scientific data on that about the listening experience.
Yeah.
Very informative.
I don't doubt it.
I asked one of the people in the show why they couldn't do a demonstration like that where you hear the same from the three sources.
Yeah.
There's only one reason for that. It's difficult. It's difficult to set up. It's not necessarily so easy, but it's not the hard. If you go to a good store and you set up and you say, I'd like to hear these things, I'd be happy to play you digital and analog on the same recording. So, you know, come to me up in Bel Air, I'll do it for you.
Yeah, it's a weird thing. I was telling people at the other seminar where I had no turntable to work with, and I did it all pantomime, which was really fun. The Beatles at the BBC came out, and those are not good recordings. It was mostly of radio transcriptions, and they did the best to clean them up. And it came out on CD, and it also came out on vinyl, and I got the vinyl 3-record set, and I played the CD, and I enjoyed the music, and there were interviews with the 4 Beatles, and they played, and they're talking, and it was interesting.
It's very fun.
Yeah, it's fun. It was to hear them talking.
It's a must.
And then I played the record, and the record, for whatever reason, just sounds so much better. And then, when John Lennon started to talk, I literally almost jumped out of the chair. It sounded like he was talking right in between my speakers, that there was a person there, not an electronic thing. Now, how can that be? It was the same digital source. Whatever is being added from that, whatever that's doing, makes it sound more real. And people say, oh, it's an additive distortion. All recordings are additive distortions. All recordings are nonsense. You cannot take a symphony orchestra and put it into 2 microphones. So everything's being played with on the way to your ears by somebody or other. So if the last step of playing with it is you getting it on vinyl and playing it on a record and it sounds more real, who cares? I know who cares. The digital people who go crazy when you say that. They go crazy. I was on a panel the other day. It was about, we had digital people there and analog people. It was Ask the Editors, and one of the digital guys, the computer guys, he was really angry about that people are playing records. I said, I don't care that you listen to CDs or you like to download music or stream it. I'm happy with whatever you like. Fine. Why are you so upset that all these people like to play records? What's going on? Are you not happy with what you're doing, that you're angry that we're happy? I don't know what it is. Any other questions I can answer for you? That's it. I explained everything so well. How many of you are now going to get an inexpensive cartridge and try to set it up? You really should do it.
Does anybody want the bent cantilever cartridge to play with?
Oh yeah, we have a gift to give away too.
Who wants it? It's yours. Come up and I'll give it to you.
you can actually try to straighten it out.
And it might actually...
You might. In fact, one time I got to fix Brian Wilson's turntable. I'll tell you the story since we have some time. This was a friend of mine who's a doctor, and he's not a music guy, and I was living in Los Angeles, and he called me one day and said, "Hey, you want to see a real goof?" I said, "Well, what's going on?" He goes, "I have to bring the drugs up to this guy, Brian Wilson. You know who he is?" Yeah, I know who Brian Wilson is. He goes, "So you want to come? It's a real scene." I said, "All right." So I went to this really nice house in Santa Monica on the mountain, and we go in, and there's a high chair, an adult-sized high chair, and you know, the tray of a high chair, the one that comes up, it's got burn marks on it from cigarettes, and below the high chair, the whole wooden floor has got burn marks, and there's a stereo there. It didn't look like it was working, but it was there, and all of a sudden, Brian Wilson comes around the turn. He's wearing a big diaper, and you know, he's talking like, "How you doing?" He was in the worst shape that he was ever in, and he says to me, he says,
He's doing better now.
he's much better.
Much better.
Yes, we all know that. So he says, I play some music for you, but my stereo is broken. And I'm thinking, his stereo, Brian Wilson's stereo is broken, and the people here can't afford to fix his stereo? I mean, what kind of travesty is that? It's sadistic. I said, "This could be your lucky day. What's the problem?" Because I'm here by accident. He says, "My turntable is stuck." So I went over to, it was a Dual 1209, and I used to have one of those, and so there's a plastic cam inside, and it had gotten frozen. So I unfroze it, just had to be turned a little bit. I got some Vaseline, and that's what you use in there to lube it up, lubed it up. It worked. The stylus was bent like that, but it was metal, so I got a tweezer from the nurse, and I straightened it out, and I got a record and put the first record on. He just collapsed and was crying and just...
Sergeant Pepper, right?
No, I don't. It was some gospel record he wanted to hear, and you know, it was like one of these moments that you think of in your life that, you know, I got to fix Brian Wilson's turntable. And then DCC reissued Pet Sounds, and the publicist showed it to him, and he remembered that he called me. He remembered when I fixed his turntable, and it was like, those moments are like amazing. So we have this book to give away too. It's a book about record collectors, and I'm not in it, so I don't want to own it. It disgusts me that he didn't call me. So how should we do this?
How should we do this?
Totally random. Whose last name begins with the letter B? Yours does? No. Whose last name begins with the letter L? Liar? Oh, sorry.
Who helped you the most during your presentation?
Yeah.
We're thinking about, how about pick a number between 1...
This guy did help me the most during the... He did. How many think he should get it?
I think the 14-year-old record collector should get it.
Are you a 14-year-old record collector? That's what my wife says about me. She says, "You're a 14-year-old record collector," except you're probably more mature. Okay, so I think we should, yeah, okay, so there you go. We applaud 14-year-old record collectors all the time. Okay, now, and who are you giving this mess to? Did you find someone?
Does anybody want the cartridge to play with? No?
He wants it
I'll
too.
take it. You can have that too.
All right, good.
Can you comment on the difference between moving magnet and moving coil? I physically know the difference.
Yeah.
But do you have a preference, or?
Moving coils, because of the lower mass, and for a bunch of other reasons, resolve more detail. They're faster, they're cleaner, if you set them up correctly. If you don't, they can sound very bright and hard and terrible, and some people don't like them because they don't set them up right.
Can I say something real quick about that?
What's that?
If you're spending less money, you want it, if you really budget, probably a moving magnet
Yes.
will sound better, and moving magnets typically have higher output,
Right.
making them a better match for a budget system.
Right.
If you're spending over $1,000, then you start looking at moving coils. But you talk to somebody who knows, who can help you, and people like me can help. Michael, there are a lot of people who care about this and are passionate, who can help you.
I answer all questions to everybody who emails me on my website. I answer every reader question, which keeps me up all night, but it's important to do that. So this Ortofon 2M series is terrific. So the blue is good for $200. The bronze is even better. The 2M black, which is about $800, is an amazing moving magnet cartridge. It's got a Shibata stylus, which is very severe. In fact, I have, this is a replicant stylus that Ortofon uses. It's very similar to a Shibata in some ways, in the severity of the cut. So this back edge is actually what's reading the vertical modulation, and you can see the sharpness of these edges. So it's going to get in the groove. So this is not a tracking issue, it's a tracing issue. So it's going to really get all the information out of the groove really well. The sharper the stylus profile, the more information it can dig out, but also the more difficult it is to set up. But a 2M black, which is a moving magnet cartridge, is a fantastic cartridge. It's $800, so it's not inexpensive. But if you have a moving magnet section to begin with, you can go up to something like that without having to worry about adding a transformer or changing your phono preamp, and it can sound really, really good.
Cleaning records?
Cleaning records. So my second DVD covers cleaning records. And I don't know who's got it out there. But since I did that DVD, we now have ultrasonic record cleaning machines, which have changed everything. But they're not inexpensive. But you can get a spin clean for $79, and it will get the records clean. It's a little bit of, it's labor intensive, but that is the least you should do. Anything less than that, it's just a brush, you're not going to have clean records. And the records are dirty, so the stylus is going to wear out faster because of the dirt. So it's worth the investment just for that purpose, but it'll sound much better with a clean record. So the spin clean for $79, the record doctor for, I think it's $3.99. You can find that online. It's basically like a nitty-gritty, but you turn the record by hand. It's not automatic. And then you can spend $600, or you can spend thousands and get a ultrasonic. Or if you're in a club, you buy an ultrasonic and you pass the machine around to each person. That's the best. The ultrasonics are, but it's $4,000. Or there's a guy out here, VA, who has one for $2,000, I think.
And there are people building them. You can build an ultrasonic cleaner pretty easily. I can give people details if you need.
You just have to be careful about how much cavitation you apply to it, which is the bubbles, the scrubbing bubbles. You don't want to damage your records. Any other questions? No other questions. That's fantastic. Well, we have another...
One more thing about digital and analog that I was thinking about. Analog is infinite, okay? Digital is truncated. Perfect Sound Forever CD wasn't right, mostly because of the limited resolution. High resolution competes with analog better because it's higher resolution. The CD is a bad compromise for resolution, and then aggravated by some neat things that happen in analog and things that happen particularly to record. But it's also a big resolution issue. With enough resolution, if you have a native digital recording, it sounds really great, but if you have a native analog recording, records really do shine. But new music recorded in the digital domain with full resolution sound really good. But Michael and I listened to mostly things that were recorded in analog.
But even new music, I mean, Bob Dylan's new record, I don't know whether you like that. Bob Dylan, Frank Sinatra, have you heard that? The night they called it a day. But he recorded that at 192/24-bit, and Al Schmitt did it. He was one of the great engineers. You know, Al Schmitt did Nat King Cole and Frank Sinatra, and he's still at it. And they recorded it live with Bob's band standing around him, all with minimum miking, nice leakage in the microphone so you get a sense of space, 192/24-bit. So Al Schmitt did a rough CD resolution mix for Bob so he could play it in the car, and Bob picked the track order, and that was that. Then Al Schmitt assembled the high resolution files and sent it to the late Doug Sachs to be mastered at 192/24-bit, and Bob got the files back. I didn't like what it sounded like. I don't like the sound of that. Do it again. So Bob did it like 3 times, and Bob rejected it after Doug did it 3 times. So Doug said, I'm done. And then it was sent to Greg Calby in New York. He did it 3 or 4 times, and Bob rejected that also. They ended up releasing the rough CD mix. That's what Bob liked the best. So the final master of this recording, done at Capitol, this beautiful 192/24-bit recording, is a CD resolution file. And that's what was used to cut the record. So the vinyl is, and when you buy the record, you get the CD in the package. So play the CD and play the record and tell me which sounds more like a live band playing in a space. It's the record, for whatever reason. And if the converter at Sterling Sound is better than the converter in your CD player, there's a good chance it will sound better on the record for that reason. But for whatever reason, it sounds better on the record. Okay, well, thank you all for coming, and I hope you all try this yourself with an inexpensive cartridge first, and then work your way up until you break a really expensive one. No, I'm saying.
I have an integrated Hafler amp.
One second, get the cartridge, and give them the instructions, and...
I have an integrated Hafler amplifier, so I could use either the magnet or I could use the coil with the photo amplifier.
Oh, it's got both? The Hafler's got moving magnet and moving coil inputs?
I can't answer that.
It's probably moving.